In this module of the course Power BI, we are going to talk about data modeling and relationships. Now, it's not that relationship that is in your mind right now. These are the relationships of data with itself, right? So we'll see how data has its relationships and how we can model data in order to solve complex problems. So first of all, as usual, in this module, we are going to talk about introduction to data modeling in Power BI, how we can model the data in Power BI. But before that, what do we even mean by data modeling? So we'll talk about that. We'll also talk about data normalization. We'll also talk about types of relationships. Obviously, first we'll discuss what is relationship, and then we'll see what are the different types of relationships in data. Then we'll see what is star schema and what is Snowflake schema, and what are the differences or similarities between both of these schemas in very simple, very, you can say, layman terms. We'll also practically create relationships between the tables that are available in the data. Okay, so if we talk about data modeling, or what is data modeling, so data modeling is basically a process of designing the structure of your data. So if obviously we have data in the shape of tables and rows and columns, right? So we have a proper structure of the data. So we need to design that structure in a way within Power BI, obviously, so that it can be logically representable, right? The information is logically representable, and we can perform efficient data queries on this data. Okay, so in Power BI, basically data modeling involves a lot of different steps. For example, defining tables. I hope you guys so far are familiar with tables. Table is nothing, it's just a collection of you can say column and rows. It is simply a worksheet in which we work on Microsoft Excel, or you can say a CSV file, right? So we'll see how we can establish relationships of different tables, right? So if so far we were working with only one table, right? That was the sales table. Now we'll try to work with multiple tables, and we'll see how we can establish relationships between those tables. And before that, we'll also see why it is important to establish relationships between the tables, right? And finally, in data modeling, there is another part that is called creating calculated columns and measures. I've given a different color to this line, that is a yellow color, which means that we are not going to discuss this thing, creating calculated columns and measures, in this current module. We are going to talk about this thing in next module, but this is also a part of data modeling. You can say this is a post-processing of data modeling, or this is a use case of data modeling, right? So in short, we are going to structure our data in a way that we can establish relationships, and we can efficiently fetch, retrieve, or update or delete the data that is available in our database. Let's talk about data normalization. That is the actually basis of the need of relationships, right? So this is you can say denormalized data, or you can say the abnormal data, right? So we need to normalize this data. So first of all, let's explore what is the thing that is bothering us in this data. It looks pretty much good data, neat data, but what is the one thing that is bothering us? So if we have a look at the column names, we can see we have employee ID over here, we have first name, last name, date of birth, department, salary, project name. Okay, so I'll circle it. Then start date, end date of the project, obviously. So these start date and end date are related to project name, right? And then we also have a skill name as well. Okay. Now, if we have a look at first two rows, this row and this row, all the information is exactly same in almost all the cells except the skill name. So this person name, first name is John, last name is Smith. So John Smith has a same date of birth that is available in both cells. He belongs to the same department. He has the same salary. He is working on the same project, but entries are duplicated. Why? Because of the skill name. Because he has two skills. One is SQL, the second one is Python. So just because of these two cells, we need to duplicate all the information that is available over here. Now imagine what if John Smith has maybe 100 or maybe 10 scales. There will be 10 rows with a similar data, but only difference will be of skill name, right? What if later on we need to change something? We need to change the salary of John Smith. We need to make changes in maybe 10 or 20 or maybe 100 rows, wherever we find the data of John Smith, right? So that is something bad. That is called denormalized data. The data is not normalized. So we need to write data in such a way that data repeats itself at minimum level. Ideally, it does not repeat itself at all, ideally, right? And even if it repeats itself, then it should be the minimum. So how can we manage this thing? Even if you look at this Jane Doe, again, the scales are different, rest of all the things are same. So just because of the two skills that are available over here, we are basically adding two rows over here. So this is a problem that we want to solve. So if we denormalize this data set, if we normalize this data set, it would look something like this. What do we mean by this? What do we mean by normalization or denormalization? So here we have divided that one table that we had in previous slide into three further tables. For example, here in employee set, we have employee ID, that is a new column. Then we have first name, last name, date of birth, department, and salary. That is the common for all the employees. Since we had 3 employees, John, Jane, and Michael, so we have only 3 rows over here, right? And then talking about the skills. Overall, how many skills did we had previously? We had 1, 2, 3, 4, 5 skills, right? So we have listed those 5 skills over here with the skill name and skill ID, right? And here we have different projects. So we have a project ID, then project name, start date, end date, and department. Now, we can create relationships between these tables in a way that whenever we want to see employee John Smith has which skills, we can fetch it. How can we do that? For example, here in the skills table, we can add another column that would be called as maybe EID, employee ID, right? So in employee ID, if we looked at the previous slide, this John Smith had 2 skills, SQL and Python. So we'll say John Smith, here we'll add the ID of John Smith. For example, John Smith ID is 1. So 1 will be added over here and 1 will be added over here as well, right? So Jane had another 2 skills, so we can add the ID of Jane at respected row number as well, right? So by using this technique of normalization, we can reduce the duplication of data in each table. Now, if I want to fetch look at the what are the skills of John Smith. The skills are not available in this employee table, but I can go to its related table, that is the skills table, and I can see wherever the employee ID is 1, that is the employee ID of Jane, these are the skills that belong to Jane, right? So this is how we can work with it. And this was a very rough example. Where do we, in which table should we create the ID? How these tables could be related to each other? This is a complete different science, and that science is called relationships. So we are going to discover this science in next lecture. Talking about relationships, let's just have a quick look on official definition that says relationships define how tables are basically related to each other. Okay, what kind of relation is it? And the critical for combining data from multiple tables in a single report. It is the same example that I gave you in last lecture. What if I have to fetch the data of skills by using employee table? I have an employee that is called James Smith. I want to find out its skills. Since these two tables are related to each other, so I can fetch the data from one table by using the reference of another table. So basically this is called relationship. Okay. So what kind of relationships are overall supported by Power BI? These are one-to-one, one-to-many, many-to-one, and many-to-many relationships. Overall, these are 4 types of relationship, but we will concise these 4 types of relationships into 3 types of relationships. Okay, so let's study each type of relationship. For example, what is one-to-one relationship? As this name suggests, 1:1. So one record in one table can be related to only one record in the other table, right? So for example, if we have such a restriction that each employee can have only one project, right? This is the project table. So there will be one-to-one relationship. Each project can have only one employee, and each employee can have only one project. So this would be a one-to-one relationship. Obviously that would be a dumb thing, but maybe some industry would have such a restriction. So that would be one-to-one relationship. So each row in employee table would be at max related to only one row in projects table, and vice versa. It is the two-way relationship, right? Okay, now talking about one-to-many relationship, as name suggests, each record in one table will correspond to one or more records in another table. So if for example, just the example that we discovered over here, employee and skill, each employee can have multiple skills. Maybe some of employees will have only one skill, but there could be employees who will have more than one skills, just like John Smith has SQL and Python skill as well. So this kind of relationship is called one-to-many. So one employee can have minimum one skill and maximum more than one skill. There's no limit of maximum, right? So this is called one-to-many relationship. There is another relationship, that is another variation of this relationship, that is called many-to-one. So this is one-to-many and then many-to-one. That is just the opposite of this one-to-many. Then we will start reading from this skills table. So many skills can have one employee, right? So this is just the difference of how you read these relationships. And then finally we have many-to-many relationship as well. I hope you guys can figure out what is this many-to-many relationship. Let's see what it is. So multiple records in one table can be related to multiple records in another table. What is the use case? So here, practically speaking, one project can be assigned to multiple employees. Obviously on one project it is quite possible that more than one employees are working on one project, right? And same goes out for the employee. Maybe one employee is also working on more than one projects. So it is both ways. So many employees can have many projects, or many projects can have many employees, right? So it works like this. Okay, so if we have a look onto the diagram of relationships, for example, something like this. So one employee can have many skills, right? And many skills can have one employee. Okay, and many employees can have many projects. Same goes out, many projects can have many employees. This is how you can read out these relationships, right? So this is how these things are called relationships in overall data modeling, and specifically in Power BI. In next lecture we'll talk about what is Snowflake schema and what is star schema. So if we have a look at this model, this is called the model of the data, right? So since we have some relationships created between the tables, here in this model we have 3 tables, and we have some relationship between the models, so between the tables, and so this is called overall a model. So in this model we have one main table that is employee table for now, okay? And rest of the tables, I keep calling tables as model, I don't know why. So rest of the tables are basically related to this main table, right? So we can say that this is the fact table, and the tables that are related to this table are the dimensional tables, right? So in other words, we can say these skills and projects are dimensions of employee. And again, listen to this sentence, it will make sense. Skills and projects are dimensions of employee. So employee is going to be the fact table, the main table, right? And these skills and projects are the dimension tables in this particular relationship. Or in other words, in any data modeling scheme, whatever you can say, whatever table you see that is the center of attraction, that will be the fact table, and rest of the tables would be the dimension tables. So this is just the terminology thing that I wanted to let you guys know. Now we wanted to talk about star schema and Snowflake schema. So what is the star schema? Star schema is nothing where we have one fact table and there are several different dimensions of this fact table, right? in our case, we have only 2 dimensions, skill and projects, but there can be more than 2 dimensions as well. You might be wondering that a star has only 5 dimensions. So what if we have more than 5 dimensional table or more than 5 relational tables? So this star is just, you can say, a symbol of this schema. Okay, this kind of a schema. You can surely have 100 dimension tables as well. So this is just a symbolic representation, right, where you have one centralized fact table, and then you have multiple dimensions that are related to this fact table. So this kind of a schema is called star schema, right? It looks like a star. Moreover, if we have a look at the snowflake schema, and you just have a look at the diagram of this snowflake, here in snowflake you will have one fact table in the center over here. Let me just show you guys like this. Okay, so you will have one fact table over here, let's call it f1, and then it will have several dimensions, right? This dimension, this one, this one, this one, and maybe more than these dimensions as well. Okay, now this dimension here, maybe there will lie a further another fact table, right? Maybe let's call it f2, and this fact table will have further dimensions. Okay, so this, and maybe at the end of this dimension there will be maybe another fact table, and so on and so forth. For example, here if we talk about projects, maybe projects will have further, maybe there will be another table that is related to a project that is called requirements of the project. Okay, oh, my handwriting is so beautiful. So there could be requirements of a project, so there could be a further table like this. So if we have such kind of schema where a dimension table has further dimension tables, so this dimension table will be acting as what? As sub fact table. So this kind of a schema is called snowflake schema, where there are more than one fact tables, right? So in star schema we have only one fact table. In snowflake schema there can be more than one fact tables, and surely they'll be related to each other, and relations are exactly the same that we have discovered previously, right? So that is the only difference. I mean, people complicate these two terminologies a lot, but this is as simple as I have explained. Alright, so now let's see how we can create relationships in Power BI, right? Practically creating relationships. For that we need some data, and here we have some data, right? This is the same data sheet that we are working on which we are working so far, the sales data sheet, or you can say the orders data sheet, right? So here you can see we have further sheets as well. This is the returns sheet. It has two columns. One is returned, that says this order was returned, right? And then we have an order ID as well that corresponds to which order was returned, right? So here we have the order ID, and here we also have the order ID. These two columns in different tables are basically the link to create the relationship, right? And then we have a people column as well. So here we have the customer names, right? So this is the person name, region name, and so on and so forth. So here we have the names of the person, and in orders we have this customer names, right? So if I'll expand it, you can see these are the customer names, right? So this column, customer name, will be related to this column that is called person, right? So first of all, let's import the data. So we'll say get data. So we want to import from Excel, and we'll go over here. Okay, so we have it in Power BI. Data, and in data folder we have this sample stores XLS that corresponds to Microsoft Excel file. So let's wait, it will take some time to connect it. Okay, so this kind of a window will open up that will list all the tables that we have in this sheet, right? So I'll check all the tables that I want to import. It is previewing, and I need this orders table, I need this people table, and returns table as well. Again, we have transform data option as well that we will discover in the upcoming modules, and so for now we assume that this data does not need any transformation, so we'll simply load this data. Okay, so it will take some time. It will take some time to process the queries. Okay, great. So after waiting for some time, here we have the data, right? Orders table, people table, and returns table. So if I open it up and I open this table up and this one as well, so here we have all the columns, but for remaining tables, we have column 1, column 2. The column names are not visible over here. So if I go to the data view and I want to view the people table, so here the person is at this second number. So basically the column name is over here. So if I double click over here, or I can go over here as well, in order to change the name of the column, I can write person over here. Then I'll select this column 2 and I'll name it as maybe REGION, reason, right? So now we have proper column names for this particular table. And for returns table, again, this is column 1, so this should be returned, and this should be the order ID, right? So ORDER, order ID, right? So now you can see the proper column names as well. Okay, so this third tab, the first tab is for visualizations or creating the reports. Second tab is for the data view, and third tab is basically the model view, right? So here we can create the relationship. You can already have a look at the tables over here, and I can drag and drop to adjust their locations for the better understanding. Okay, now here in returns table, I have order ID, right? And in orders table, I also have here the order ID, right? So I can create relationship between both of these tables based upon this order ID. So how can I create the relationship? All I have to do is I'll have to click on this table name, drag it. I don't have to lose the click button. Keep pressing it, drag it, and drop it over here. And wait for a second. Here we go. So it has automatically created and detected the relationship. It says 1 to many. So this static is a symbol of many, right? So one return record over here can have multiple orders over here. So you can also edit this relationship as well if you want, right? So this is one relationship. Second is person and region. So person and orders table. So here in orders table, we have the customer name where. So yeah, here we have, right? So I'll drag it and drop it over here. And let's see. Great. So it is again one to many relationship. One people or one person can have multiple orders, can have one or more than one orders, right? So this is how these relationships are created. Now, one more thing. If I'll go to this report view and let's create a table over here. And in the table, what I'll do is I'll go to the orders and I'll drag and drop the states over here, right? So all the states are listed over here. Cool. Now, I want to check out how many order returns are there with respect to each state. So if I'll go to orders, I have no information about returned orders. But if I go to this table, returns order table, I have some information over here. So I'll go over here. Now since I have created the relationship, so I can go over here and I'll drag and drop this order ID over here. And it is simply showing up the order ID. I'll come over here, this option, and I'll say show the count. Okay, so I'll show the count. So it is showing the count, that is 297, which is not accurate, right? Because the total is 297. So why it is not accurate? By the way, what is it showing? It is showing how many orders are returned in Alabama state, and so on and so forth. And I repeat, both of the informations are coming from two different tables, right? Both of the columns are coming from two different tables. Why? Because we have created the relationship over here. But it is not, both tables are not communicating in accurate manners. So I'll simply double click on this arrow. Okay, and it will open up this edit relationship option for me. Here I can also manually mention that this relationship should be created on which basis and stuff like that. And by the way, I should be going to this arrow, not, I want to edit this return and order relationship. So I should go to this arrow, not the not the other one. So here the order ID and order ID in both the columns are related, but here you can see cross filter direction, right? It is single. You need to make it double so that it can both of the tables can communicate to each other. Moreover, it says here we can mention the type of relationship as well. So if we say if we find out that Power BI has not automatically detected the relationship correctly, then we can manually figure out the correct relationship over here as well, right? So it has all the list of those 4 relationships, right? Okay, and also you have to by default it is checked. If you will uncheck it, the relationship will be inactive. So if you will check it, now relationship is active. So I'll click OK. Now I'll go back to the report view, and here we go. So now count of orders. In Alabama, there is 1 cancelled order. In Arizona, there are 9 cancelled order, and so on and so forth. In California, there are 127 cancelled orders, and so on and so forth, right? So this is how you can work with the relationships. You can edit the relationship, you can create the relationship, and so on and so forth.